Welcome to section 4.4, where we're going to multiply polynomials. In this lesson, we're going to multiply a binomial and a binomial, as well as multiplying a binomial with a trinomial. In order to multiply binomials with a binomial, we're going to use the distributive property or using the box method to multiply. And when we do that, we are going to multiply the coefficients. So 2 times 3 is 6. And we're going to add the exponents. X times x would be x to the second. And then 2 times negative 1 is negative 2. And the x term just gets rewritten. In order to multiply binomials, we're going to use the distributive property, or you can also use the box method to multiply. And to do that, we are going to multiply the coefficients and add exponents. And then after multiplying, we're going to combine like terms where we add and subtract the coefficients. One way of multiplying binomials is by using the distributive property. The acronym FOIL stands for first, outside, inside, last, and it helps you organize how you're multiplying and distributing these binomials. We're going to multiply these binomials because there's no operation in between those parentheses, so that's assuming. Before we begin, there is a typo. Please change this subtraction to an addition. And now we will use the distributive property to multiply these binomials. We are going to first distribute the x to the binomial, and then we're going to distribute the negative 2 with the binomial. If you have a hard time seeing this as a negative 2, feel free to add the opposite. So now we can really truly see that that is a negative 2 being distributed. Our first terms in FOIL would be x times x, because they're the first numbers in both binomials. And x times x, remember we add the exponents, keep the base, add the exponents. Now the outside would be the x and the 5 because they're on the outsides of these two binomials. And x times 5 is really the same as 5 times x. Now we're going to distribute the negative 2 to the x as well as the negative 2 to the 5. And so the inside terms are negative 2 times x because they're the inside of this bi times a bi. And negative 2 times x is negative 2x. And then the last terms are negative 2 and 5 because they're the last ones in the binomial. And negative 2 times 5 is negative 10. Now that we're done distributing, which is essentially multiplication, now we need to add or subtract our polynomials if there are like terms. And there are here in the middle. They have the same x and the same variable on that x. So our first term, 1x squared, that just stays x squared. And we're going to do 5x plus negative 2x, or 5 minus 2x, which is 3x. And then I'm left with a negative 10, so I'm going to write minus 10. There are no more like terms because the exponents of these are not the same. So our answer ends up being this trinomial x squared plus 3x minus 10. Another way to multiply a binomial by a binomial is by using the box method, and this is a really nice way to organize your terms. Once again, that typo, please make sure there's an addition sign so that we can compare the two. So since it's a binomial times a binomial, I'm going to make a 2 by 2 box. And one of the terms, x subtract 2 or plus negative 2, is showing on one side. And the other side of the box, we're going to have an x plus 5 because we changed the sign. It could be the other way as well. You could use the x plus 5 on top and the x minus 2 on the left side like that as your factors. All right, now we're going to fill in the box by multiplying. So here for this box, we're going to do x times x, and x times x, remember we add your exponents. All right, the next one is this box, and that's going to be x times negative 2. And negative 2 times x is negative 2x. Now, the 5, we're going to take 5 times x to fill in the bottom left, and 5 times x is just 5x. And the last terms here were the negative 2 times 5 to fill in our bottom right box, and -2 times 5 is -10. So we still get the same 4 terms as earlier, and now typically you'll have like terms in this diagonal. And now that we're done multiplying, it's time to add or subtract like terms. So our first term, x squared, there's nothing to combine that with. 5x minus 2x is 3x, and minus 10 is in the end. We get the same trinomial answer as we did from the beginning without wondering, did I distribute it correctly? It's nice and organized in that box. Now we will multiply 4 different types of a binomial by a binomial that look the same, except the signs might be different in each example. I will use FOIL on some to show the distributive property, and then I will use the box method for some to show that distributive property. For the first one, let's use FOIL. So the first terms are the first numbers in each one, and x times x is x squared. Now we're going to distribute the x to the second term, and x times 5 is 5x, and those were the outsides. Now the insides is 3 times x, and now the last terms, 3 times 5 is 15. Once we add or multiply, now it's time to combine like terms, and they're typically in the middle there, but we're looking for the same variable and exponents. So I still have an x squared term, a 1x squared. 5x plus 3x, I'm going to add the coefficients and keep the variable part, and then add 15, there is no other constants. So our final answer is this trinomial. For the second example, I see that there's multiplying, so I'm going to use the box method this time to organize my multiplication. So I have x minus 3 for one of my binomials, and my other binomial I have an x minus 5. All right, let's fill in the box by multiplying x times x. We keep the base and add the exponents. -5 times x is -5x. -3 times x is -3x. And -5 times -5 is +15. Now that we multiplied, now it's time to combine like terms. So inside of x squared plus -5x and -3x makes -8x. And +15, there's not a like term for that, so we just rewrite that. So we combined those like terms and we're left with a trinomial in the end. Let's use FOIL again. So first terms are x times x, which is x squared. X times, that's not a +5, that's a -5. And with the box method, you're more likely to see that as a -5, because you actually throw that negative with that term. All right, inside is 3 times x, and distributing the 3 times the -5 is -15. Combine like terms. X squared, this is technically -5x and a -15, so careful there. -5 plus 3 is -2x, and plus -15 is the same as saying -15. For our last example, I noticed that the binomial times a binomial, so I'm going to make a 2x2 box again. One binomial as one factor, and the other binomial as another factor. So x times x, we add the exponents, that's x squared, the base 2 times. Next one, -3 times x is -3x. So I really saw that as a -3 times x, where here many kids see that as a positive, but it's not. It's a -3. All right, next one, we have 5 times x, which is 5x, and 5 times -3, which is -15. Now that we're done multiplying, combining like terms, we've got x squared, -3x plus 5x is 2x, and we have a -15 still. Now looking at these trinomials, they are all very similar. They have 15s or -15s at the end, and in the middle term is either 8, -8, or 2 or -2. So there are some patterns to notice here. We had a positive 15 because these were positive here, and 5x and 3x were also positive, making it 8x. Here we have a -3 and a -5 that made a +15. But those -3 and -5 added up to a -8. Here we had a positive and a negative as your binomials. And so when we multiply positive and negative, we get a negative. And notice -5 is bigger than 3, so it added up to a -2. Here we have -3 and +5, making a negative product. And the 5 and the -3, the 5 was bigger, so this time we subtracted and kept the sign, and it was a positive 2x. So just kind of look for patterns as you're multiplying, because in the future, we're going to take these answers, factor it to get these binomials. I encourage you to hit pause and try these yourself, and then double check after I'm done. I will do one with a box method and one with FOIL for the distributive. All right, my first terms, 5 times 5 is 25, and x times x is x squared. Now the outside, which is distributing, 5x times -7, which is -35x. Now the inside terms is -7 times 5, which is -35x. And we have a -7 times -7, which is a +49. I see lots of mistakes with negative errors, so be very careful if you're not using the box. Now that we're done multiplying or distributing, we're going to add or subtract, and I do have like terms. So my first term is a 25x squared. My middle term is going to be -35 and -35, making -70x or -70x. And then I have a +49, my only constant. My trinomial is done. All right, now that I notice that's a binomial times a binomial, I'm going to write one factor on top and the other factor, careful, that's a -5y on the bottom there. All right, let's multiply. 5 times 2 is 10, and x times x is x squared. 4 times 2 is 8, and then I have an x times y. I'm going to write it in alphabetical order. 5 times -5 is -25, and I also have an xy. And -5 times 4 is -20, and y times y is y squared. Now, when I combine like terms, because I'm adding and subtracting now, I only have one x squared term. And here, whether it's x times y or y times x, they are like terms because multiplication is commutative. That's why I rewrote this in alphabetical order. So I really see that the labels are the same. So I'm going to add the coefficients, and -25 plus 8 would be -17xy. And then my last term is just a -20y squared. There are no other like terms because they've got, they have to have the same variable and exponent. Now we're going to multiply a binomial with a trinomial, and we can still use distributive property, but this time FOIL doesn't work. That only works for a binomial times a binomial, but the box method works for everything. Then, like before, we will combine like terms if there are any. So this time I have a binomial times a trinomial, so I'm going to distribute the x term to each of the 3, and then I'm going to distribute the 2 to each of the 3 terms. And that makes 6 distributions in all. So FOIL is for 4 distributions, not 6. So we really truly do have to use the distributive property here. So here we go. X times x squared is x to the third. We have to add our exponents, and there is a 1 there. X times 4x is 4x squared. Then we have x times a -7, which is -7x. Now it's time to distribute the 2 to each one of those. So 2 times x squared, I was taught to write it here. You may want to write it down here, because we're going to combine them in the end, and then we can line up those like terms. So that's kind of cool. So I'm going to write plus 2x squared over here, because that's what a lot of kids will do. And then 2 times 4x is 8x, and 2 times -7 is -14. Now, to combine like terms, we've got an x cubed and only one of them. We've got an x squared with another x squared, and that would make 6x squareds. We have a negative 7x plus 8x, so that's 1x. And then we have a minus 14 in the end. Let me show that second distribution one more time. The 2 times x squared, you could write it down here. The 2 times 4x is 8x, you could write that there. And 2 times negative 7 is negative 14. And then when you line them up, you can see there's only 1x cubed. And 2 and 4 is 6x squared. And negative 7 and 8 make 1x, and then we have that negative 14 by itself. So typically a binomial times a trinomial will result in 4 terms, which is called polynomial for all general polynomials. The box method is definitely my favorite way because of the organization. Now we have a binomial times a trinomial, so this time I'm going to put my binomial there and my trinomial here. And you could also do it this way. 1, 2, 3, x plus 2 and x squared and 4x and negative 7. You could fill in the box that way as well. It does not matter. All right, here we go. X squared times x cannot be x squared. We have to add our exponents, x to the third. 4x times x is 4x squared. Negative 7 times x is negative 7x. Now that bottom 2 times x squared is 2x squared. 2 times 4x is 8x. And 2 times negative 7 is negative 14. Now that we multiplied, it's time to combine like terms. We only have 1x cubed. And do you see the pattern here? 3, 2, 1, and then 2, 1, 0. That's very typical, so it can really help you find mistakes. So in the diagonal, I have 2x squared and 4x squared, making 6x squared. I've got 8x and a negative 7x. That makes positive 1x or just plus x. And then my negative 14 has nothing else to combine it with, so my binomial times trinomial turned out to be this polynomial. Double checking with the last page, we got the same answer, 2 different methods to distribute. Please hit pause, try this one on your own, and then double check in the end, please. If you chose to distribute, this is what we'd be getting. I used to just line them all up, the 6 terms, but I saw this trick later on, I thought was cool. So that's a negative 12x squared, I'm gonna line up the like terms. Negative times a negative, which a lot of you might miss, is positive 15x, and a negative 3 times 1 is negative 3. Combine like terms, add them up, 8x cubed. I've got a negative 10 and negative 12, and I've got a 15 and a 2, and a minus 3. So if you did it that way, there you go. If you did it with the box method, I really like doing it this way more than the vertical way. Whatever you'd like to do. Negative 5x and positive 1. If you wanted to do it this way, it does work as well. Maybe you challenge yourself by doing that. All right, 4 times 2 is 8, and x squared times x is x to the third. All right, multiply the coefficients. Negative 5 times 2 is negative 10, and x times x is x squared. 1 times 2x is 2x. So that looks good. I do see a pattern, x to the third, x squared, and x. Probably did it correctly. Next one, negative 3 and 4 make negative 12x squared. Negative 5 and negative 3 make positive 15x. And negative 3 times 1 is negative 3. My like terms are typically diagonal from each other, and it looks to be that way here. So my first term is that 8x cubed. My second term are combining these 2 boxes, negative 10 and negative 12 make negative 22x squared. And we have a 5x and 2x making 17x and a minus 3. Both ways give you each of those methods. So now that we've done that, can you multiply a binomial times a binomial? And can you multiply a binomial times a trinomial? Can you picture what a trinomial times a trinomial would look like? You would have to distribute 3 times for each of the 3 terms, making 9 distributions. Or you could make a 3 by 3 box, and typically that would be much easier. All right, good luck with your assignment, and I hope you learned how to distribute.